All right. The key to this problem is to draw a really good dog. Okay, so you've got you got the ground here. You got your sled. I'm picturing the Grinch, right? Here's that poor dog, you know, with his antelope things on, pulling the sled like this, right? Anyway, 215 kilogram sled. And there's a friction force of 782 newtons on the sled, right? So we'll just draw that force up here. 82 newtons. And the horse is pulling on the sled forward. But apparently the sled is decelerating, right? What is the deceleration of the sled? So it actually, even though the dog is pulling, right, the sled decelerates. So the force that the dog is exerting, I'm guessing, is smaller than 782 newtons. Okay, so let's first calculate the deceleration. We've got the initial velocity, final velocity, displacement, right? So let's do that. SUVAT. Okay, so the initial velocity is 6.2. Final velocity is 0. Displacement is 8.25. Right, and then I would use what v squared is u squared plus 2as. Right, final velocity is 0, so we have negative u squared over 2s is a. Do a little math there, right? So the opposite of 6.2 squared, all right. Okay. So what I'm saying here, I'm trying to say this in the right way. Well, here, let's do this squared inside there, right? So negative 2, 6.2 squared, then negative, right? Divided by twice 8.25, right? It's tricky, right? So, okay, divided by 2 times 8.25. I get the acceleration is negative 2.3296, and that repeats. That's kind of cool. Okay, so there's our acceleration. We've got the force here. We don't know that force. We know the acceleration. We know the mass. We're set. We're using F equals ma, and we go force, unknown force, minus 782 equals, what's the mass? 215, right, times negative 2.3296 repeating. Okay, so that times 215, and then I'm going to add, I've got this side here, I'm going to add 782 to both sides, so plus 782, and I get 281, oh, that's cool, 1151 repeating newtons, which I guess we would have to say positive 281. All right. I love that.